Hello, everybody. Welcome to today's webinar, Engineering Your Digital Transformation, hosted by DevOps.com, and the content is brought to you by Plutora. We're going to hear from Gary Gruver, well-known author and industry expert. My name is Chris Riley. I'm a DevOps industry analyst, and I'm going to be moderating today's webinar and wanted to put out a few housekeeping items. You can hear us, but we can't hear you. So if you have any questions during the webinar as you think of them, please type them in the question dialogue and we will get to those. Jeff and Gary will respond to those at the end. And also, this webinar is recorded, so it's going to be shared with a link after the webinar. Make sure you circulate that around with your peers. And finally, we have 3 Amazon gift certificate gift cards for $50, which is a giveaway that we are going to announce the names of those winners at the end of the webinar. So make sure you stay tuned to that directly after the Q&A. So without further ado, I'm going to introduce Jeff of Plutora, and he's going to take it away.
Thank you very much. I'm really excited about this session. We've done a number of sessions with Gary, who's super well known in the industry. If you haven't heard of him, you should go Google his name. He's actually working on some new content and an exciting new book, which I'll let him take the lead on. But uh, you know, why Plutora is here with Gary is, frankly, we help make the software factory visible. We help measure the progress of digital transformation. We help the process of showing how are we doing and what we're doing to speed up delivery, improve the quality, and ensure alignment of the business with IT. And Gary is going to show you from an engineering point of view, how do you help transform that? What does that look like? So without further ado, Gary, take us away.
Thanks, Jeff. Do you believe that the effectiveness with which you develop and deliver software matters to your business? Do you believe that your organization can be more effective in terms of how it develops and delivers software? But do you struggle to get organizational alignment around what are the types of things that you should improve? And then when you make an improvement, be able to show the impact of the improvement? If you do, you're like a lot of people out in the industry that I work with on an ongoing basis. And if anybody knows me very well, since I delivered my first book over a decade ago that delivered outstanding business results, I've been spending all my time and energy trying to figure out how to help other people realize the benefits that we're able to achieve because it had such a dramatic impact on my life and others. I do webinars like this as often as I can to help people understand what I think works and what I think can be improved. I do workshops. I go within companies and I do specific workshops to help them analyze their deployment pipelines, figure out what to fix, and then coach them along the journey. And I tend not to engage in organizations unless I can stay there with them on the journey, because it's one thing to help you understand what to do. It's another thing to really help you avoid common mistakes along the way. And I write books like The Practical Approach to Large-Scale Agile Development, and I promised myself I would never write another book because it's so painful and hard process, and I wasn't sure that I had anything new and unique to say on the subject. So I've committed to myself I wasn't going to write another book. Last fall, that all started to change. I'd been working with a lot of clients and I'd been watching them struggle to deliver business improvements at the rate that I felt like they should be. And I did a marketing tour through Europe and visited with a lot of different clients and watched them struggle to figure out how to demonstrate the impact of their improvements and how to prioritize them and how to get people aligned. And it was starting to annoy me a little bit. And I started thinking back to my career where I grew up as a manufacturing process engineer. And in manufacturing, there's a much more structured approach to driving continuous improvement, and it has a lot more engineering rigor in it. And I started thinking that really what we need in software is not just what we've traditionally done, which is try these latest practices, whether they're agile practices or DevOps practices or Kanban or Lean or whatever. It's less about trying the practices and more about how do we come up with a systematic approach for driving improvements. And then I went to DevOps Enterprise Summit in Las Vegas, and I started talking to a lot of people, and the comments were more like, yeah, we should just do exactly what manufacturing did. And that didn't fit well with me because I grew up in manufacturing, and as I moved over into software, I realized we couldn't do the same things because software is very different. It's digital, it's different, but we could leverage from a more systematic approach. So I started thinking about it more and more, and started by looking at, what was done in manufacturing. And you start with some key leaders out there. Deming, kind of the father of the quality movement, went to Japan after World War II and helped them understand the importance of building in quality, how to build in quality, and really process control and those types of things. And he took Japan from being a country known for low cost, low quality products to a leader in manufacturing worldwide known for outstanding quality. And then Goldrat, who really focused on flow and how to really improve the efficiencies of organizations, started by thinking about how do we understand the constraint in the process and how do we optimize the constraint. And people who really implemented his theory of constraints approach in manufacturing on average saw a 70% increase in capacity using the same people and the same equipment. If you were able to, in your organization, see a 70% improvement in productivity with your same people and your same equipment, do you think your business could figure out something to do with that excess capacity and how to go after that? And then the third leader that I really focus in on is Tiache Ono at Toyota, who came up with the Toyota Kata process, which is a very structured, systematic approach and culture for driving continuous improvement across the organization. And within that, Toyota became the organization that was able to dominate as an automobile manufacturer. And on average, they see 70% higher gross margins. It's important to understand the types of things that were done in manufacturing because they've been proven successful over decades and decades, and they've been refined and fine-tuned over decades. But having been in manufacturing and being in software for the past couple of decades, we can't just copy what manufacturing did because software is different. In manufacturing, when you want to build a prototype, it's a fairly labor-intensive process. It's hard to build. You need to coordinate bringing all the pieces and parts together, and that's difficult. And in software, it's very different. The manufacturing process of give me an environment, build the code, deploy the code, run a test so it's ready to deliver is a process that's very easy to automate. It's very easy to set up from the very first line of code. So we don't have to wait until after the product's done or at different prototype phases to try something. We can be building the code on an ongoing basis. And that process that we use to build the code and deploy it on an ongoing basis does a lot to define the productivity of the organization. So in manufacturing, they design the product and then they go into manufacturing it. In software, we need to do both the designing the product and using the manufacturing process at the same time. And manufacturing uses the stage gate R&D process, which is they have different phases of an investigation phase, then a prototype phase, and a manufacturing prototype phase, and then a release to manufacturing, because they realize at each gate, the costs of development go up and the capital investments that they're making, and the ability to change goes way down. So in manufacturing, they use a stage gate R&D process. That's the beginning of the software development product lifecycle. In software, it doesn't make as much sense because we don't have those cost increase and it's not difficult to change as we go on. The other thing that's unique in software development from manufacturing is in manufacturing, we're trying to build the same thing over and over and over again with as limited variability as possible. In manufacturing or in software, the product changes every time you run the process. So we can't use the same approaches. And in manufacturing, the process is creating the product. And in software, what we're seeing is people that are writing the code are creating the process or product. So we need to be able to incorporate those changes. The other really unique thing is in manufacturing, it's very visible as what's going on. You can see inventory building up in the factory. You can see when two parts don't go together well. The visibility that we have in manufacturing enables us to do a lot of improvements and drive those improvements into the organization. The challenge that we have in software is when we go to look at our software process, it typically looks like this. Maybe we can walk around the floor and see engineers working on something, but as far as the flow, where inventory is building up, where the quality issues are, we really don't have visibility of any of those types of things. And in software, if we're going to be effective, we need to do a much better job of getting visibility of what's going on in our organizations and how to do it. In manufacturing, they typically start with a product design. They design it well. It has the bill of materials, all the different pieces and parts that need to come together. And once they have this laid out, they've realized that how they design this product has pretty broad implications on how they manufacture it and the lifetime's efficiencies. There's an approach called DFX, which is designed for X, where X can be either manufacturing, it can be supply chain, it can be quality, it can be all those different things, because manufacturing realized a long time ago that how they design the product has broad implications on the rest of the system. And there's a lot that we can learn from that. Once they have this design, the next piece that they go in and do, and for us, you know, in software, our product design, instead of being something looks more like the architecture. That's all the pieces and parts that need to be assembled and put together to deliver something of value to their customer. Once manufacturing has the design, they design their supply chain. And the supply chain really talks about each sub-assembly, where am I going to, you know, assemble which parts, how am I going to put them together, how am I going to assemble them in the final factory, where am I going to distribute them to. And in manufacturing, they think a lot about manufacturing in the lowest cost regions, which parts go together, but they also think about where they hold inventory, because if you hold inventory all the way out at the store, there's a lot more demand variability. So, you know, a customer could walk into one store and not another. And what they tend to do is they have those regional distribution centers where they hold inventory, because what they're trying to do is reduce the demand variability. In software, we have a similar supply chain or distribution channel like this, but it's how do we get an environment, how do we do a build, how do we do a deployment, how do we assemble all those pieces. And one of the first steps to making improvements is really getting in here and trying to understand our deployment pipelines or our version of our supply chain. For a loosely coupled organization where you have a few developers that can independently work, you can have developers work together, they can coordinate, they can move into a test environment, and they can move directly into production. And this is a lot of what you hear talked about in DevOps. This is the idea that I've got a loosely coupled system where these people can work independently, they can control their deployments, they can make these things happen. I've had a lot of debates with Gene and Jez over the years that a lot of the stuff that they're talking about really applies to loosely coupled systems, and we need a different approach for tightly coupled. And we'd had this argument long enough for enough years that the latest DORA report in 2017, they went and tested for architecture. And the conclusion that they came to was that, yes, architecture is one of the biggest indicators of success in being able to successfully do DevOps. That is to say, if you have a loosely coupled architecture, you're more likely to deploy more on a more frequent basis, and you're more likely to have lower quality problems, and you're more likely to have smaller batch sizes, all of which are good things and easy things to do. And I fundamentally agree with them that if you have a loosely coupled architecture, you're going to be much more successful in doing DevOps. It's a lot easier. There's a lot less coordination. But having led large re-architectures of large systems, I'm not sure I'd recommend somebody starting there and doing that as the first step. you know, the comment I had with Jez is, okay, well, we finally agreed that loosely coupled is different than tightly coupled. And he goes, yeah. So now we just need to have everybody go do a that's tightly coupled, loosely coupled, and re-architecture. And it's like, ooh, that's painful. I'm not sure you've ever done that, and I'm not sure I'd recommend that as a first step. But I do think this idea that we need to treat loosely coupled differently than tightly coupled is key to thinking about how we go through things. And if you've got a large tightly coupled system like this, ideally what you would do is you would go in and just do continuous integration like you do on a loosely coupled system, do canary releases and that. But the reality is you can't build these systems frequently enough and test them frequently enough to get a small enough batch sizes to enable you to find and triage things very efficiently. So when we have these large tightly coupled systems, what we tend to do is try to break them up into smaller subsystems with service virtualization to enable us to qualify subsystems differently. And we go from this type of architecture into making our tightly coupled deployment pipeline visible. And one of the best ways to do this in your organizations as you go through is start with the environment, start with knowing where your environments are and working through those pieces and figuring out how code really does move through the system. And I don't think that you can really think about how do you apply improvement concepts until you've made your tightly coupled system visible. And one of the recommendations, if you just look at the research and benchmarking, is this: if you have a tightly coupled systems, you should decouple it. That's a pretty painful process. I'd recommend more. What I see as I go into organizations that have this is they tend to struggle with the coordination across teams, and they tend to struggle with building quality in, which is to say they batch up a lot of inventory over here on this side and hold it until they reach a milestone like development complete, and then they pull it over into an environment here and they start building in quality, and it takes them a long period of time to go from when development's complete to when they're ready to go into production. And the first step is really understanding how to improve this is starting to make this factory visible. The next thing that I see in a lot of organizations is the time that it takes for them to go from development to complete into production is longer than the businesses are willing to wait. In those instances, what they tend to do is they tend to take this manufacturing line and they just copy it by making a bunch of duplicate branches. We'd never do this in manufacturing because the factories are very expensive and hard to build, and maintaining 3 different factories is very hard. But because software is easy to branch and easy to do, we tend to copy it and duplicate our manufacturing process a lot. And there are a lot of inefficiencies and waste associated with that. It's not as bad as it is in manufacturing, but it's there. So the steps that we really need to take to understanding how to deal with a tightly coupled system is making our factory visible, and that includes all the duplications of factories that we have in the system. This is with a large tightly coupled system that owns deployment. We have a lot of different types of organizations and a lot of different types of applications. And one of those applications is custom off-the-shelf software. And this is software like an ALM tool or a ERP or an MRP system, maybe your SAP systems, your HR systems, where it doesn't make sense for you to develop it internally, but you tend to purchase it and then you apply customizations within your organization to figure out how it's modified. And when you don't own the deployment, it introduces a lot of unique challenges because you can't just do A/B testing, you can't do canary releases. You're very dependent on your clients or your customers for when they deploy code. And what happens in these organizations is you tend to end up with more of this duplicate work. You tend to have slower release cycles, you tend to have a lot of these duplicate factories, and you tend to have waste associated with that. And the types of things that you would do to improve the flow down these lines is more associated with how do I control the deployment process? How do I get rid of the waste and inefficiencies associated with multiple branches and going through that piece? And then the other type of deployment pipeline that you can have and applications are these embedded applications. And this is, the LaserJet examples. We're seeing more and more of this in automobiles. The Internet of Things is really driving a lot more embedded software into the organizations and across things. And the challenges you have here are fundamentally different. Yes, you don't own deployment, so it's similar to the custom off-the-shelf software that we need to improve. But you also have some code that can be developed on a simulator. You have some code that can be developed on an emulator. And then you have some code that needs to be tested on the final product. And the challenge here is trying to figure out how to do as much of the work in terms of writing code, defect fixing, and solving things at the common node of the deployment pipeline, similar to in manufacturing where they try to aggregate inventory at a node on this side over here where there's less demand variability. What we're trying to do with embedded software is we're trying to replicate the work, and we're trying to do as much of the work over here at a common node in the deployment pipeline where we can run the test once and fix it once and find things that way. When we go in to look at how are we going to do things, the first steps we have here is trying to make these deployment pipelines visible, because the product design has implications on the deployment pipeline. We can define for it to be more efficient, and the different types of architectures that we look at, the different types of architectures that we work on have different challenges. We can't just go off and benchmark what loosely coupled organizations are doing and apply that to tightly coupled systems or embedded systems or customized off the shelves. We need to apply the engineering rigor to understand the types of problems that we're dealing with. And in manufacturing, they have common principles, but they have different practices that are designed to address the unique issues or challenges that you have it. And we need to do the same thing in manufacturing. We need to take the time to make our factories visible so we can analyze and figure out what to do. The next area that we can really learn from manufacturing is building in quality. Deming really took that. They've created a culture. There's such a culture of quality, and building it in manufacturing that started 50, 60 years ago. And in software, it's much more natural, and the culture norm is to build up large batches of inventory and inspect in quality. If we're going to fundamentally change our improvements and drive changes, we need to really focus in on what are the changes that we need to make to enable us to build in quality. And in manufacturing, they focus on quality control charts. And they do that because it's the process that's creating the product. And when the process goes out of control, they need to fix it and they need to monitor it. And this is how they built in quality. And while we can learn from the culture of building in quality, software is fundamentally different in that it's not the process that's creating the product, it's people, it's engineers, it's developers, and it's not a control limit on a tolerance on a manufacturing line. Manufacturing is typically pass fail. And the types of things that we need to do to build in quality is really improving the frequency and quality of feedback that we give to developers and helping them improve things while they're actually writing the code. This is one of my motivations for writing the book, is I've seen so many organizations go in and start trying to build in quality before they have a stable quality signal. And I finally came to the conclusion after watching lots and lots of organizations struggle with this, that we need to take a much more systematic approach. And within this, what I do is, let's go somewhere on your deployment pipeline, ideally as far to the, back over here, as far this way as you can. If I end up trying to run this experiment too far back here, I'm only helping the limited number of people working on component A. If I'm working further to the right, the number of people that would see the benefits from building in quality is higher. If I end up going too far right, I may not control what's going on in that. It's beyond my level of influence. So we're going to start by picking an environment that I have control of, that I can start to run this experiment. And the first thing I'm going to do is I'm going to take that environment, I'm going to take all my automated tests, I'm going to run them 20 times in a row, and I'm going to dump the data into the database. It's the same environment, it's the same deployment, it's the same code, it's the same everything, and I'm going to run my test 20 times in a row, and this is typically what I see. There'll be a lot of tests that are always passing because the code is good and the environment's good. There'll be some tests that are failing because there's a defect in the system that needs to be fixed before the test can pass. But what I typically see is a lot of tests that toggle between passing and failing. If you have tests like this that are unstable and can't give you a quality signal, and you still go and start asking your developers to respond to this feedback and build in quality, your transformation is headed for a train wreck, because you're asking developers to debug and triage stuff that's not real, isn't effective, they can't get their code in, it's not working, they're frustrated. So the first step we're going to do is we're going to take all those flaky tests, we're going to set them aside, we're going to take all the failing tests and set them aside until I get the defect fixed and can bring them back in. And then we're going to go through a systematic step of understanding what it takes to get to a stable quality signal. And this one, we've talked about step 1 and step 2, where we selected an environment and then we run the test for repeatability. Next, I want to make sure that I can run these tests in random order, because I want to be able to run them in parallel against the system. Run them in random order, run them 20 times in a row, dump them back in the database. Typically in this situation, you'll see another group of flaky tests that come into the system. We need to set those aside and triage and debug them. Next step that we need to do is ensure that the environment is stable under load. Most people will go in and take an environment that they've used for manual testing, and as they start doing more automated testing, they'll start using that for their automated testing. And what happens is those aren't necessarily stable under load. So what we're going to take is all of our good tests that we can run in random order, we're going to point all those tests at this environment, we're going to run them in parallel, and we're going to see if we can run them 20 times in a row and get the same answer. And frequently what I find is that's not the case. It's unstable. There'll be a flaky F5 in the system that times out, that has problems. Or I had one client that had 4,000 automated tests that they ran every Monday. And I said, well, why don't we run them every day so we can do a better job of triaging and sort of doing small batch sizes? And the individual responded, I can't, I got to spend the rest of the week debugging and triaging these. The environment is so small that the tests time out, and I got to go back and run all the failures over and again to see if they're really failures, and I spend the rest of the week doing debug and triage. For them and that organization, before they could get a stable quality signal, they needed to add some CPU and RAM to that environment so that it could handle the load and wasn't timing out. If you don't take the time to really drive all those issues to root cause and make sure that you have a stable environment, your ability to build in quality is going to be undermined, and the frustrations that you're going to have driving a transformation are just going to be stopped. So you need to take the time to make sure you do that. The next step is ensure your deployment process is stable. In this case, to take the same code in the same environment, but in this case, you deploy the code and run the test, deploy the code and run the test. And what you're trying to figure out is the deployment process increasing any more instability in the system? If it is, you probably need to automate and clean that up. Next, we're going to run the same experiment with create an environment, deploy the code, run the test. Create an environment, deploy the code, run the test. Do that 20 times in a row. And if that's not stable, if you can't reproduce and create the environment on an ongoing basis, and that's increasing instability, you need to resolve and solve those issues once and for all before you can really start building in quality. There's a really good example of Optum technology. Ted Ewell, we did a earlier Plutora webinar on that. It's available there. It's probably on devops.com. It's available on my website also, where Ted really talked through all the steps that he took to create a stable quality signal. And for him, this took several years, but in the process, he took a lot of waste and inefficiency out of the end game and helped improve that. And as you're starting to do a digital transformation, One of the biggest changes that we can make in software development is building in quality instead of inspecting it in, but we can't make that change unless we have a stable quality signal. And I would encourage you wholeheartedly to start running these experiments and see what we can do to improve the quality and improve the flow. So we've talked about making our factory visible. We've talked about going from our architecture to that piece. We've talked about getting a stable quality signal so we can start to build in quality. And the next thing that we need to think about is how do we optimize flow through our organization to make sure that we're being as productive and efficient as we possibly can. In manufacturing, they started with the idea of theory of constraints, which is in the factory, it's not about making sure everybody's busy working on all the individual cells, because there's typically one step in the manufacturing process that's the constraint, and each step in the manufacturing process runs through a product or a batch of products together, and the cycle times, how long it takes to do that, and you can use that to calculate where inventory will build up in the system in front of it. And Goldratt spent a lot of time focusing in on that and figuring it out, because if you can improve the flow through the bottleneck, that improves the flow through the entire organization. One of the challenges that we have with software is it's hard to measure flow. In manufacturing, you can count the number of products, you can count the number of things coming down the line. In software, every time we run the process, the product is a different size. You know, a feature is going to be a different size, a line of code is going to be a different shape, a new application is going to be a different size. So we can't measure it the same way that we can other things. But what I've learned in going and working with more and more organizations is that we can measure the waste that's slowing down flow, and we can focus on that. And in the manufacturing process for software of, you know, get an environment, build the code, deploy the code, run the tests, that costs the same amount of money and takes the same amount of line for one line of code and 100,000 lines of code. The bottleneck, there's not a natural bottleneck in the manufacturing process for software. And because of that, the natural incentives have been to batch up inventory into large sets and run them through the system together. But that overlooks the bottlenecks that occur outside the manufacturing process, primarily defect triage and fixing. And that gets much harder with these large batch sizes. So when we start looking at manufacturing, the bottleneck typically starts with repetitive tasks, the manufacturing process of build, with it's most likely test if you've got any manual tests in your system. And we need to automate that to where that's not slowing down the flow. But the next thing that it tends to go into is defect triage and fixing. And to do that well, we need to go to much smaller batch sizes that make it easier to find those types of things and work on the defect triage and fixes. And one of the things that manufacturing does is when they have a defect in the system or they have a problem, they tend to pull the andon cord and stop the line. And they stop the line because they know the process is creating the problem. And if they continue to let the process run when it's creating defects, it'll just create more defects. Software, we're very unique in that respect, where it's not the process that's creating the product, so we don't need to stop the process. We can gate the code. So what we want to do is try to get as much of the bad code trapped and not let it go further down the line, and give the feedback to the developer while they're working on the code. At the same time, we can let the good code continue to flow down the line. So the most common approach to this is gated commits, where when somebody commits code, it doesn't make it to trunk until it's passed this set of automated tests, and we've gone through that process. And we can gate the code when people commit, we can gate it the application. If you look at the deployment pipeline, you can put quality gates in at the subsystem. You can put it as the subsystem goes into QA. You can put them in each step in the process that enables you to make sure that the defects are captured as close to the source as possible so that defective code doesn't get it down the system. But once I've gone through the process of sending the bad code back to the developer, I don't have to stop the line because that bad code hasn't gotten onto the trunk. I can let the good code continue to flow through the system and become much more efficient that way. The other thing that we need to start to think about is what is the waste that's slowing down flow? You know, in software, we've always looked at, can we measure story points or can we measure lines of code? And I think all of those are bad measures of productivity or flow because I can game every system. But what I've realized as I've worked with more and more organizations is, while I can't measure flow, I've gotten very good at measuring waste that's slowing down flow. And in these situations, I can look at the delay in feedback. So once I've mapped my manufacturing line, then I can go in on it and say, how long does it take to move from the subsystem into QA? And in this case, it's taking 4 weeks. And then the next thing I can do is map on top of these different environments the percentage of defects that I'm finding where. And so in this case, where I've got, 4 weeks into the process, I'm finding 60% of my defects, I can't expect my developers to get better and learn from that feedback. And if I'm going to improve, I either need to improve the cycle time or reduce the time it takes to move through these different systems, or I need to get much better at finding the defects much further to the left in the system and getting them fixed up there. And that helps to address the delay in feedback and the waste associated with that. The other thing that's unique in software is we can automate a lot of the repetitive tasks, and when we can, then I don't have to worry about doing defect triage fixing of any of the issues associated with test or environment or deployment or data issues, and I should primarily be finding code issues. So I can start to measure across all my different environments where I'm seeing issues that are not related to code, and we really can't make this transition to building in quality until the code issues are the primary things I'm finding. So in this case, I need to focus a lot on getting my test issues resolved, re-architecting my test automation, coming up with better design patterns. I need to go after my environment issues. I need to go after my deployment issues, but I can measure the number of times that I'm seeing these things, and then I can go in and make a change and measure the changes that I did to say, hey, I did infrastructure as code, all of a sudden my environment issues have gone way down, or I re-architected new design patterns and a new test framework, and I can see my test issues go way down. So in this type of case where you've been able to get people to agree to fix things, you can quantify and show the waste that has come out of the system. The other thing that's challenging is in manufacturing, we learned that inventory is risk. We're at risk of finding different quality issues when we put it together, and we want to maximize flow by minimizing inventory. We haven't done a very good job of making that visible in software, and we need to change that if we're going to continually improve. And we do that by documenting the inventory that hasn't been integrated into the broader system. In this case, we've got 40,000 lines of code that hasn't been integrated down into the subsystem one, and we've got 50,000 lines of code that hasn't been integrated into QA, and 70,000 lines of code that hasn't been integrated up here. So what we're doing is we're making the inventory risk that's inherent in our software manufacturing process visible, so that we discourage people from holding up batches of inventory on feature branches, team branches, or any of those different things, because what we find is this inventory that we have up here, we're delaying the feedback from interactions that it might have with either the subsystem 2 or subsystem 3, and manufacturing would never do that because they realize when they put it together, they're likely to find other quality issues. And with software, we need to take that same philosophy and same approach. The next thing that we really need to think about is creating a culture of continuous improvement. In manufacturing, that was a lot of what Taiichi Ohno taught at Toyota. And he didn't just create a culture, but he had a systematic approach to driving improvements, measuring improvements, that he taught everybody in the organization how to use. And if software is going to be as effective, we need not only that culture, we need that systematic approach. And those systematic approaches are going to use metrics so that we can measure the impact. We didn't go much into product metrics, and we just, in 40 minutes, we have an opportunity to just do a brief overview of all these different pieces. What I provided here is an overview of a series of webinars that we're going to be giving that's based on my new book, Engineering the Digital Transformation. We'll go deep into each of these different approaches, from process metrics to building inequality to flow. If you want to get ahead so you have better questions for the next webinar, you can feel free to get my book. It'll probably be out next Wednesday and available. Or if you're going to DevOps Enterprise Summit in London, Jeff's going to have a few at the Plutora
at the booth.
At the booth, yeah, at the Plutora booth, that he's going to be able to hand out to go there and read up on it. What I've tried to do is give a very systematic approach for driving these improvements and getting these changes that is not only something that can be used, but it can be taught. People can be in a common approach, and you can start applying these to deliver sort of breakthrough improvements for your organization. And this is really what I feel like is missing in the software organization, is the ability to measure these things, drive improvements, show improvements, and quantify the things that will have the biggest impact. Hopefully this brief overview has been helpful. If you'd like a copy of my slides, please send an email to garygruverslides@gmail.com. And with that, I'm going to hand over to Jeff.
You bet. I wanted to just take a moment and to say, why are we talking about all this together? We're all here to go faster. We're all here to reduce our batch size, deliver better solutions to the business, provide value to customers. And in a word, I like to think of it as disrupt or be disrupted. The Plutora solution is a solution on top of your current application delivery. We help manage that. Uh-oh, Gary, I think we lost a slide there.
Sorry.
The point is that our platform offers a way to integrate on top of your current whatever you're using today, whatever you're doing today, and to help bring that visibility into the help you see what's happening on the manufacturing floor. We do that through three basic layers. There's an integration common data model into the layers of your tool chains that exist there, in essence, to help make the work visible across the tool chains, converging them, if you will. We have a management orchestration layer to from pipeline orchestration, environment management for managing those pre-production test environments that we're talking about, even into doing cutover and those go live events. Whatever level of automation you're at, we can help orchestrate that and incorporate that automation in. And finally, and one of the most important areas is the analytics and comparative metrics and predictive insights that you'll see on top of the data that we pull into our cloud-based model. And what that gives you is true insights. It gives you the ability to start looking forward, do what-if scenarios of what's coming, and that's why we're here. That visibility gives you insights into where to change, where are the bottlenecks, what things you need to address next. If you jump to the next slide, one of the analysts out there, Forrester, has released a wave on value stream management. You jump to the next slide, Gary. It basically gives some outline of how do you actually manage value streams and what does that look like. We're part of that wave. Come to our website, you'll see that. And some of the details that are included in that space. So with that, we have a few minutes to dive into questions and so forth for Gary. I've got a couple here. If you go to the question panel, feel free to ask questions and we'll include those there. I've got a couple here that I'll get started with that have come in. This one's really for you, Gary. When you get started working with an organization, what metrics or information do you gather to start working with them?
Yeah, I really started what we just walked through here on a high level, and we'll go into more details in the other sort of webinars as we go down, because it's hard to get much of a deep dive in 40 minutes. It kind of just skimmed over the top, but I really start with architecture. and I start with trying to make the deployment pipeline visible. And one of the reasons I like partnering with Plutora is that's the value that they bring. When I go into organizations, I frequently find it's hard for them to gather the metrics. It's labor intensive. It takes a lot of effort. And I think what Plutora can do is come up with some standard views and make that data capture much easier. And it's more than just a one-time thing, but you capture it on an ongoing basis. So it's really, I start with this idea of let's get that deployment pipeline clear and obvious. And one of the easiest ways I do it when I go into organizations is tell me about the environments you use. Because what I found is that when I try to get too much information at once, it gets lost in the details. If instead I'm like, okay, you got production. What's before production? You have a staging. What's before staging? Do you have a UAT environment or a QA environment or a dev environment? And then what's your architecture? And frequently what I find is they really haven't taken the time to think through that. And a lot of what this exercise of mapping it out does is it starts to make visible how things really work in the organization so that they can make improvements. So I start there. I tend to see if they can run those sets of experiments for building in quality. And I go into organizations that frequently can't even run that because they can't build more frequently or they can't deploy more frequently because it's all manual, or it's a situation that they can't run the tests because they're in an environment where they're in an integrated test environment and they either have to set up the data or they can't, the back end system, somebody's deploying to it while they're trying to run their automated tests. There's just an amazing number of things that you'll flush out in the system by just running through those experiments to build in quality. And then I start to put the metrics that are starting to slow down flow. And once I've got that overview that kind of defines the biggest issue, we tend to do a workshop and we get together and we sort of review what I was able to identify were the biggest sources of waste. And then the organizations will go through and prioritize the improvements that they think will have the biggest impact on driving changes and going through that piece. So those are the steps that I take and the process that I go through, and then I coach them on a monthly basis, because one of the things that's unique with me relative to a lot of other consultants in this industry is a lot of people will either be hands on keyboard doing the coding, or they'll just come in and give a presentation and leave and never come back. And I like to stay engaged because people aren't really ready to listen until they feel the pain of specific issue. And one is, I'm not necessarily in a position to tell you everything you need to know up front because I'm not that smart. We need to go down this journey together and point out common mistakes. And the advantages I get is I get to work with a lot of these different implementations so that I can see common issues and try to call those out either through my webinars or my workshops or my books so that people can avoid common mistakes and focus on making new ones.
Very cool. Can you talk about a little bit on the branches? You started discussing some of the branch problems. How do you get people to reduce branches, and talk about some of the more of the waste of the multiple branches?
Yeah, there's two types of branches that I see. One is back-end branching, and that's where you can't get the code out quick enough, as quick as the business needs it, because you're not building in quality. So that's basically you're duplicating your manufacturing line. You got to have all the different computers for all the different environments. You got people running tests and debugging and triaging. So you're taking your resources and diluting them across more and more different places. So that there's waste associated there. A lot of organizations struggle to be able to run enough testing, and basically every time you see a branch, you're just diluting your testability. And then when you do defect fixing, you've got to do it in multiple places. So one of the advantages of software is once you've developed it once and qualified it, you should be able to use it as many places as possible, as quick as possible. That benefit goes away when you start branching. So you're branching for a reason on back-end branching, and that is because you can't go from dev complete to ready for the customer as fast as the business would like to release. And the way we go after that is we start building in quality and moving away from that need. And then the other thing that tends to happen is people tend to do front end branching. This is my feature branch. This is my team branch. They're doing those things because they don't have a stable environment where they can work. So they're trying to isolate their interactions away from everybody else. And, you know, one of the things that we do for back-end branches is we just make it visible. You know, I would imagine most of the executives in your organization don't realize there's all the inefficiencies associated with that. It's a build team somewhere that's branching it to make it more efficient and make it work. And if we realize the work that was driving in the system, we could focus on taking that out. And then we make the inventory visible to make it clear that we have a huge amount of risk in our system because people are choosing to do feature branches and team branches and all those different types of things. And they do that because there's not stable environments. But as we move to creating quality gates into the environments and we work to increase those quality gates so those environments are much more stable, then it's a more efficient place to work and people can get away from having these feature branches and team branches and not integrating their changes with the rest of the system, because all you're doing there is delaying feedback and you're building up a bunch of code based on some assumptions that you thought would work, and when you integrate with something else it doesn't work. So that's the waste associated with that. And you know, it's right now in most organizations that waste is not visible at all. And I think one of my beliefs is if we're going to get it fixed and resolved, we need to start by making that stuff visible.
Mm-hmm. Very good. How do you see these principles changing based upon industry?
Well, I wouldn't say necessarily industry as much as I would tightly coupled, loosely coupled. You own your deployment, you don't own your employment, you're embedded. So the principles of building in quality, maximizing flow, those things I don't see changing industry-wise. Now, how I fix it, right? If I'm a tightly coupled system that owns my deployments, I can do one thing. If I'm a tightly coupled system that doesn't own my deployments, typically the biggest thing that's slowing down flow is not. It can be building in quality and it can be loosely coupling, but it tends to be more optimizing that deployment process. Right now, we have lots of organizations where it's really hard to add the customizations, do the automated testing, and differentiate between a defect associated with a new version coming from the supplier versus a defect associated with your customizations versus an easy way to do testing. Those are the types of things that you would fix to do that. And I think in our next webinar, we'll do a much deeper dive into here's all the different types of applications, and here's the things that you would do to continuously improve for those different types of applications.
That's going to be really cool. For those that are, IoT is on the rise. For those pipelines that have a mix of IoT with traditional, and they're trying to do a hybrid style type delivery, what advice do you have for improving those?
That we'll go into that really in depth in the next one, and a lot of it has to do with embedded devices are typically optimized for saving the next penny and driven a lot of hardware variability in, which was fine when there wasn't much software in the product. But when those products start to differentiate more on software, that hardware variability really drives the software development efficiencies way down. We either need to reduce the hardware variability or abstract the hardware variability away from the majority of the software with a nice hardware abstraction layer. So we're trying to move as much of the software to where it can be developed and qualified on a simulator that had a lot less variability. And I think if we go back to here, what we're trying to do is move as much code into simulator-based code as we can, reduce the number of emulators that we have to test on, and move it to where we can do most of the testing on an emulator or simulator by investing in those emulators and simulators. So it's really making those investments so that we can get those improvements and changes out of the system.
Awesome. There's a question about the slides and where to go there. I think we have a couple of different email addresses, but certainly we can get those out. That'll be part of what's up on devops.com as well. This webinar is recorded. There's another question about will this webinar be recorded? Yeah, it's all being recorded, and it's something you can follow again. I think there is some items for, there's a gift card to hand off. Just again, from my perspective, if you're struggling with delivery, please give us a call, drop me a note. We'll help you with the process of improvement. The point is, you don't have to be stuck in the world that you're in. For what to do and how to do it, Gary is an awesome resource. For proving the value and where it's going, Plutora is an awesome resource. And together, it's a great 1-2 punch to improve your application delivery. And so with that, we'll turn that back over to you.
Yeah, thanks, Jeff. Thanks for the content, guys. This is great. Gary, I particularly love how you don't just throw out that it's a part of the manufacturing process. You actually validate not only, how it's different from traditional manufacturing and what's unique about software development. So this is fantastic. Well, it's time for the giveaway. As Jeff said, the webinar is recorded. You will be getting a link in the next few days. Make sure you share it with your peers because this information is extremely valuable, and you don't get a lot of chances to pick Gary's brain like you do on webinars like this. So I'm going to announce the 3 Amazon gift card winners. You will be getting an email with information on how to claim that. It's a $50 gift card after the webinar. So starting with the first one, it's Devoria B. And the second one is Harold O. And finally, the third giveaway is Mohammed E. So congratulations to the winners. Like I said, you'll be getting an email with the information on how to claim that. And Jeff and Gary, thank you. And I think everybody should be looking forward to the next webinar where you go deeper into these concepts.
Thanks, guys.
Yeah, thanks for having us. Look forward to the next ones and come ready with more questions. My passion and energy is around helping people do this. So if there's anything I can do to help, let me know.
Great. Thank you.